The purpose of this video is to identify particulate filter damage during the visual inspection of the core. Criteria for the inspection can be applied to all generations of exhaust after treatment. The inspection of the filter core is visual only. No special tools are required. The exhaust side of the filter provides the most detail in determining the condition of the core, and good lighting will aid in the inspection process.
Surface damage is any gouges or scrapes on the surface and cannot exceed 1/2 inch in length and 1/4 inch in width, and no deeper than 1/8 inch. Also, any loss of substrate plugs across the surface is considered surface damage. Open cells along the outer edges cannot exceed 3 rows in from the edge. Surfaces with numerous gouges that do not exceed the tolerance criteria cannot exceed a total of 5 blemishes across the entire surface area. Vertical cracks are visible at the surface and may be seen on one or both sides of the brick. Vertical cracks may propagate in different patterns that may spider across the surface or run uniformly parallel or perpendicular with the cell walls. To identify filters that have experienced horizontal cracks internally, turn the filter to the exhaust or outlet side for inspection. The exhaust side of the filter can be identified by an embossed arrow on the can showing flow and points to the exhaust side of the filter, or by careful consideration of the mounting flange characteristics. The exhaust side of the filter should have no signs or evidence of soot. Horizontal cracks run laterally through the brick. Cracking begins around the outer area of the substrate brick and propagates to the center, but cannot be seen at the surface of the brick. Internal horizontal cracks in early stages leave traces of soot in a ring around the outer edge of the outlet side of the filter. More severe internal cracks that have propagated across the entire brick allows soot to accumulate on the outlet across the entire surface in a uniform pattern. Foreign matter blocking the surface pores of the substrate cause damage to the cell plugs during removal. Contamination could be any substance that adheres to the surface of the substrate and restricts flow. Internal fusion breakdown allows soot to accumulate on the exhaust side of the filter and can be identified as spots of soot or evidence of soot in non-conforming patches on the outlet surface. Fusion or melting of the substrate brick and the severity of the failure can be localized internal hotspots known as fusion, or as extensive as complete exothermal breakdown that can be seen by massive deterioration of the cell's walls extending to the surface of the brick. Slipping of the brick can be identified by reduction of clearance from the outlet surface area to the outlet flange of the filter can. Dents that exceed 1/2 inch into the can constitutes can damage. Witness marks from clamps are acceptable unless the damage is so severe as to allow rust to penetrate through the cans. Flange damage is a distortion of the mating surface of the filter can at either the inlet or outlet clamping area, and bracket damage is a distortion of the bracket.
To correctly identify DPF damage key points such as direction of exhaust flow, specific characteristics in substrate brick damage, and soot patterns are important when inspecting particulate filter core for potential damage.